how Android views are rendered under the hood. The view tree. Element hierarchy. Imagine your phone screen as a canvas. Everything you see on it, buttons, text, images, lists, are individual components called views. These views don't live in isolation. They're organized in hierarchical tree-like structure. Some views are invisible by themselves but serve as containers for other views. These are called view groups. Examples include linear layout, arranges items in a row or a column. Frame layout, stacks items on top of each other. Constraint layout, positions items using constraints. In the end, your screen is just a big tree of views. The root is a top-level view group, and the branches and leaves are other view groups and regular views. How the tree turns into pixels. There are 3 key passes. Whenever Android needs to render a screen or part of it, it walks through the view tree and performs 3 main passes on each element. First, measure pass. Goal: figure out how big each view wants to be. How it works. Starting from the top, each view group asks its children, given these constraints, for example, you can be wider than me, how much space do you need? Each child calculates its ideal width and height based on its content, text, images, nested views, etc., and tell the parent via set measure dimension. Then the parent uses 2 sizes to calculate its own size. Second, layout pass. Goal: to determine each element's position coordinates on the screen. How it works. Again, from the top down, now that each view knows its size, the parent tells each child, you go here from X to X and Y to Y. Views remember their position. The layout logic depends on the view group. Linear layouts lines things up, relative layouts uses relative rules, etc. Third, throw pass. Goal: actually render the elements on the screen. How it works. Once again, the tree is traversed top-down. The system gives each view a canvas, a virtual drawing surface. First, the parent draws itself, background, borders. Then it tells each child to draw themselves within the space defined in the layout pass. Each view draws its content, text, background, images, using canvas drawing commands. After all 3 passes, Android has a complete picture to display on the screen. How redrawing, repainting happens, or invalidate versus request layout. What if only the appearance of view changed, color, text, but not its size or position? Then call invalidate. Tells Android, I need to be redrawn. Only the draw pass runs. It's fast and cheap. Android may also redraw overlapping views if the size of the structure changed. Edit or remove child views. Call request layout. Tells Android, my layout needs to be recalculated. Triggers all 3 passes, measure, layout, and draw. This can be expensive and should be used carefully. So what about modern optimization? Hardware acceleration. In the past, all rendering, including drawing pixels, was done by CPU. Now, most Android devices use hardware acceleration. On draw commands, don't go directly to pixels. Instead, they're recorded into a display list, a list of drawing instructions. This list is sent to the GPU, graphics processing unit, which is super fast at rendering. The GPU handles rendering while the CPU just prepares commands. This makes redrawing more efficient. When invalidate is called, the GPU may simply replay or partially update the display list. To maintain smooth UI performance, all 3 passes should complete within 16 milliseconds to achieve 60 frames per second. What hurts performance? Deep view hierarchies. Too many nested view groups. For example, linear layout inside another linear layout inside a card view. This all add overhead during measure and layout. Frequent request layout calls. For example, changing sizes during animations or scrolling can be expensive. Overdraw, redundant drawing, multiple opaque layers drawing on top of each other. For example, background, card, button background, waste GPU cycles. Use Android's debug GPU overdraw to detect this. Heavy logic in onDraw. Doing calculations or creating objects, for example bitmap, inside onDraw slows down rendering, especially if it's called often. What improves performance? Use flatter layouts with constrained layout instead of deeply nested view groups. Minimize request layout and prefer invalidate instead, when only visual changes needed. Reduce overdraw, remove backgrounds that are fully covered. Optimize onDraw, reuse objects, paint, pass, move heavy logic elsewhere. Android with rendering summary structure. The screen is a tree of views inside view groups. Rendering passes is measure, views determine size, layout, views are placed in position, draw, views draw themselves using canvas. Redraw triggers invalidate, only redraw. This is cheap. Request layout, measure, layout, and undraw. This is expensive. Improve performance, flat layout, slide and draw, lower draw. And don't do deep nesting, frequent request layout calls, heavy drawing logic. This is all from me. Bye!